When I take a look at the computer here in front and at the screen of the computer, there's the future of sim racing in 8 steps. It sounds a tiny little bit like an old story, but it's from the future, and I'm really looking forward to the future of Marcel Offermans. Ladies and gentlemen, please welcome Marcel Offermans. Future of sim racing. Marcel, it's your turn.
Thank you. Yeah, I thought I'd do this in 8 convenient little steps. But before I start talking about that, let me first introduce myself a little bit. My name is Marcel Offermans. I have been the managing director of Studio 397 until a couple of months ago. And there worked on the rFactor 2 racing simulation. Also licensed our technology to Amazon Games for the Grand Tour game. We licensed 2 motorsport games at the time for the NASCAR 21 Ignition game. And before working at Studio, I was also involved with the rFactor 1 simulation for ISI, where I did some project work, did the port to Steam, and the first Automobilista title for Ryza Studios is also something I collaborated on. So I've done quite a few things in the sim racing space. And before that, I was a software engineer and architect and spent about 2 decades designing and building all kinds of different systems, from embedded to cloud and enterprise systems. So I have quite a background in software and technology, and that will also be reflected in some of the next slides and me telling you about what I think is the future of sim racing. So let's get started with the first slide. And that is a slide about a sort of paradigm shift that's going on in computing for the last, well, really decade, I would say. If you look at computers in general, there's this law called Moore's law, which says that every 2 years the number of transistors in any piece of hardware will double, which also means that the speed of the hardware every 2 years increases dramatically. And for a long time that happened in a very predictable way. Computers just got faster, so your CPU, it just was faster every couple of years. And some of you who are a bit older will probably still remember that initially we even have computers with a little turbo button on them. And if some programs ran too fast, you could press the turbo button and it would go slower again. Now, the problem that started to evolve was that over time, speeding up computers happened in a different way. So instead of the CPU just becoming faster and faster, at a certain point in time, CPUs became faster because there were more of them. There were more cores instead of just the one. And this has quite a lot of consequence, because it also means that you need to program your software in a completely different way to take advantage of that. New languages were developed to help do that, but it also meant that you had to completely tackle some problems in a different way. And this, especially on the physics engines of all racing simulations, had quite an impact, because those were all designed to only take advantage of one single core. And all of a sudden you had to do that in parallel. And mathematically that's quite a challenge to make that happen. So if you look at current simulations on the market, most of them are quite old. So most of them were originally designed that way. And all of them now are looking at considerable redesign to actually make the physics support multiple threads, or even, because apart from the CPU, we also have a GPU nowadays, which has even more cores and is very good at specific tasks. So that's another thing you could leverage if you want to improve your physics and create better physics fidelity that way. But it's hard to change your code to take advantage of that. So you're almost certainly looking at a complete rewrite if you want to take advantage of it. So that's something that will come in the next couple of years, and we're already seeing some new simulations hit the market, and they might or might not already have such new algorithms that take advantage of all these cores. But that is certainly something that will change, and it will influence the future of racing a lot. Another point that has been discussed also in a few previous presentations today is hardware integration. But in the early days, we were already happy if we just had a steering wheel and a couple of pedals, and we could move the wheel and press the pedals, and that would actually control the car. In the early days, we also didn't have anything like force feedback. Well, if we had it, it was like just a spring, static spring that would center the wheel again, stuff like that. Next came force feedback. That's already like 15 to 20 years ago. And soon after that came a specific type of force feedback called direct drive, which really improved the accuracy and also the force of certain effects. That was great because it was a big leap. We're now at a point where we see a lot of different hardware manufacturers. So there's a lot of stuff you can choose from. But at the same time, if you look at how all this hardware interacts with the software, not much has changed at the sort of interface level between the two. You either have buttons, which are on or off, or you have axes, which for the steering wheel and pedals provide some value between 0 and 1. And that's the only way for hardware to interact with the software, which is fine for a lot of things, but for a few kind of peripherals that you want to have, it also presents a big challenge. An H shifter is a great example of that. It has different positions where you can put the shifter in, and all of those are currently implemented like just a single set of buttons. If you put it in first gear, a button is pressed. If you put it in second gear, another button is pressed. And the problem is that H shifters in real life are a little bit more complicated than that. You might have miss shifts. If you don't press the clutch, it might not go into gear at all. And all those things that we could calculate from the software side through the physics engine, we cannot communicate that to the hardware. So that's a problem. And that's something that really hasn't changed in all these years. And I think for sim racing to evolve, to take it to the next level, we need to change how hardware and software interact. And that will be quite a challenge because it will mean we have to create some new standards for that. But I think it's really important that we do that. Another example of that is how could we integrate certain real-life hardware, racing hardware, with our simulator. And if you look at that, then all cars, whether they're race cars or normal road cars, nowadays have what's called a CAN bus, which, like your network card, is just a way for different devices in the car to communicate. And a lot of peripherals in racing use that CAN bus to get data from the car. So if you have a display, for example, it will show you the RPM, and that RPM is data that's sent over the CAN bus. So it would be nice if simulators could also read and write data to a CAN bus, because that's just a little card you can just stick in your computer. And if you do that and hook up some real racing hardware that way, then you're bringing those two worlds even closer together than they are already today. That too will require some standardization and some communication between all the different vendors, but I think it's important that it happens. So I think those things are what's going to hopefully happen on hardware integration. Number 3 is the graphics engine. And if you look at graphics engines, those are usually modules that exist within the complete package of software. And a general law in software is that graphics and user interface are things that change a lot. So if you design your software, you need to make sure that during the lifetime of your software, you can replace that engine quite easily, because other parts of the engine might last 10 to 15 years easily. But graphics, it seems every couple of years there's this new engine, and yeah, that's all the rage, and everybody needs to support that. So that's something you need to do when designing a simulation. The other choice you have is, do I use an out-of-the-box graphics engine, or do I build my own? And a lot of people are choosing generic game engines, like, for example, Unreal Engine is probably the most used one right now, also in a few new projects. And it's absolutely a great looking graphics engine. It has all the bells and whistles, and it produces absolutely stunning graphics. But there's also a few downsides. When you look at sim racing, everything is happening at speed. Your car's traveling at over 200 kilometers per hour. So all of a sudden, it becomes really important that what you're looking at the screen is also the current situation. So your latency between what you see and where the car actually is, that should be as low as possible. And one way to achieve that is to make sure that you have really high frame rates. So where typical games use 60 frames per second, some even get away with 30. In sim racing, if you ask around and ask some of the esports drivers here, they will all tell you, well, you'd need at least 120 frames per second, but if it's a lot more than that, it's even better. So you need to optimize your graphics engine to allow that. And this gets even more complicated when you talk about things like triple screen support, because all of a sudden you don't have one screen, but you have three of them. And you need to render all three of them at 120 frames per second, which effectively triples the workload. So that is another challenge. And going back to Unreal Engine, for example, one of the best known examples of simulators using that right now is Assetto Corsa Competizione. And they've done a great job on that, and they have triple screen support. But I happen to know that it took Epic, the creators of Unreal Engine, to help them to actually implement that. So it's not trivial to get that to work and to get that to perform well. So that's definitely something you need to keep in mind. And the same goes for VR, where you have not 3 but 2 screens. But for VR, you typically have even higher resolutions, and it's super important that your frame rate stays at least 90 frames per second, because if frame rate drops in VR, people get sick within seconds. So you really don't want that. So those are things that you also need to take into account, and those are not always super easy to achieve with Unreal Engine or Unity or some of the other standard engines out there. So my point is, it might still make sense to create your own engine if you're building a racing simulation. Probably a crappy comparison, but if you compare it to tires, then you're not going to put street tires on an F1 car, right? You need your own bespoke tires that work on that type of car. It's a little bit like that with graphics engines as well. Moving on to number 4, sound, or actually 4 and 5 are both about sound, but they're 2 different topics. Sound is something that's really hard to get right in a simulation. And that already starts when you try to record the sounds, because recording sounds means you need to stick a microphone somewhere in a race car, and ideally you want to record all the different sounds in isolation. But it doesn't work like that in a race car. You can't just say, let's leave out the engine for a lap and we'll just record the tires, or we'll just record the wind noise. So you record stuff, and you always need to post-process it and try and filter out all the stuff you don't need. So you have all the individual sounds and then can mix them all together again. So that's a very complicated process, and it's what most racing simulations do right now. But if you want to take that to the next level, what you really need to do is, well, like with generic physics, you need to start simulating how an engine actually works. And by simulating it, you can then also record the type of sounds that it makes. And if you add a driveline to that and add tires and all of that stuff, then basically you're creating another physics simulation that will produce the exact sound that that car makes in real life. The problem is you're already running your normal physics engine. So if you had to run another one just for sounds, that's probably going to take a lot of load on your PC. Especially because, well, most car engines, and especially racing car engines, they rev at quite high RPMs. That also means that your simulation needs to take really tiny simulation steps. So it's it's putting quite a lot of load on your system if you run that in real time. Still, at the moment, there are simulations out there that do that. And if you look at the screenshot on the slide, this is one of the engines. It's actually an open source one. You can check it out yourself if you can decipher what's on the slide. You can always ask me afterwards. They actually do that, and it sounds quite impressive what they have there. But you'd have to tone that down a lot and make it a lot less resource using to include that in a simulation in real time. But there's also several efforts ongoing to create more simplified simulations based on more complex ones. And if you use special machine learning techniques, there are possibilities to create a more simple simulation that will run in real time alongside your normal physics, and will still sound almost or just as good as the more complicated one. So that's something I think we will see in simulations going forward as well. And the other thing about sound, number 5, is, well, I've titled it Ray Tracing Audio. I think a lot of you know what ray tracing is and usually associate it with graphics. It's basically a technique where you follow a light on its path from the light source all the way to the camera, and you try to figure out what kind of objects it hits along the way. And you can sort of do the same for audio. And the reason for wanting to do that is that it's nice to record, for example, a car and to know how it sounds in a sound studio. But if you've ever been to a racetrack, and my favorite example here is Spa-Francorchamps, which is in the hills. If you hear a race car running on that track, you hear all kinds of sound echoes and things that you wouldn't hear if this car was just in your garage. In other words, sound travels through the environment, bumps into all kinds of things along the way, and that gives us very specific signatures. So probably there are people on this planet who can just listen to a race car and say, oh, this is a race car racing at Spa, or this is a race car at Zandvoort, because it sounds so different from an environment point of view. It also means that you need some kind of ray tracing-like technique for the audio to properly simulate what a car sounds. And well, you could say if you're in the car racing yourself, that's not going to be that big of a deal, because as you all know, when you're in the car, you only hear one thing, and that's your own car. You don't hear anything outside of that. So for that scenario, you really don't need all of this. But on the other hand, if you're doing nice broadcasts and you're simulating cameras that go along the trackside with microphones next to them, they pick up on all of this. So if you want that to be a real life experience, you really need to go into some form of ray tracing for your audio. Like with video ray tracing, it's quite CPU intensive to make that work. So there's some trade-offs to make, and there's certainly some optimization to do before that works in real time in a racing simulation. But like I said, we have Moore's law. Computers get faster and faster over time. So at some point it will be possible to make this work, and it will make our racing simulations sound much, much nicer. So certainly something that we need to take into account, and I hope we'll see that in simulations going forward. Number 6, cheat detection. That's probably a topic that most developers are a bit reluctant to talk about, and probably for a good reason. Cheat detection is quite hard. I mean, the simple solution is, and you see that in other esports as well, if you have a tournament, just invite everybody to come over and race in the same room on standard hardware where they can't mess around with any of that. and you can watch them as they race. In such an environment, it's probably very hard to still cheat. But that doesn't scale. We can't get everybody into a room every time we want to have a race. And as the pandemic has taught us, when racing from home, all kinds of things can happen. From simple stuff like we don't even know who is really racing the car, which you can still solve by asking people to put a camera on the actual driver. But there's other stuff out there as well, and some of the more advanced stuff that people are using, unfortunately, and I know that because I've seen those programs, are tools that are very much like the modern driving aids that we have on our road cars. So things like ABS and traction control. Those are things that you can also program for a simulator, and you can program them to directly get telemetry data and actually output pedal and steering inputs. And there's no way for the actual racing simulation to see that, because you can do that in an external device. The computer won't even see that. It just sees pedals, and that's really hard to detect that kind of stuff. So that is something we will have to find a solution for that going forward, especially as prize money goes up. There will be more people trying to get away with cheating. It's an aspect we need to try and minimize as much as possible. So I expect going forward that there will be more focus from a design point of view, and also from how events are organized, to make sure that that stuff actually is prevented. And a little bit related to that is robust online. If you look at the last 20 years where we started to race online, focus has always been on making it possible to race online at all. Initially, we could only race with a few cars, and probably if you raced longer than a few minutes, you ran into all kinds of networking issues. Nowadays, you really need to make sure that you're a lot more robust than that. Races are longer. We're racing up to 24 hours. And in 24 hours, things can and will go wrong. So we need to make sure that we change our architectures there to go from a system where we have a single server and clients connecting to that, to one where we have backup servers with hot failover, as they call that. So if one server goes down, everybody just seamlessly moves to the next one, and things like that. And a little bit in the area of cheating, we also need to make sure that all of those network connections are secure. Most sims currently do not have secure connections. If you listen to the network, you can see the packets go by, and in theory, you could change those packets as well. That could be used to just disrupt the race. It could be used to maybe even cheat. And we need to make sure that you cannot do that. And other areas of software have already managed to make that work. Our financial transactions on a bank online, they have that covered. So we need to catch up on that and make sure that going forward, we also have these things to ensure more seamless racing. And final slide, esports, and that's a topic that's probably been discussed a lot already today, both in the presentations and also in a lot of the discussions that we've been having. It's definitely an important part, I think, of the future of sim racing, but it's also a topic that can be hyped a little bit. My take on it is that we first need to make sure that we have a very broad community with a lot of people driving. And once we've established that, then we have this wide base and we can start building a pyramid with national championships, international championships, stuff like that. That is important because that will create our new heroes in the sport. And we need those new heroes in the sport because eventually, if we have those high-profile events, we need something else or someone else, and that is an audience. An audience need to watch their heroes. They need to take an interest, And shortcuts could be to just invite a famous soccer player and put him in a sim and drag some people onto a broadcast that way. But I don't think that's a long-term solution, so I don't think that's the way forward. We need to create new heroes, and we need to make sure that there's an audience watching these races. And that is also a bit of a challenge, right? Because racing, even though if you're a driver yourself, it's quite interesting, but to watch a race is not always as thrilling as it could be, especially if you compare it again to some of the other esports. I mean, I've watched a few Counter-Strike tournaments. There are matches like 2 minutes, and in those 2 minutes you have like 15 moments of action that can be replayed 5 more times. If you compare that to sim racing, you probably don't get that much action. I applaud the people here at RCCO for doing some online competitions and having really short head-to-head sprint races and trying to be a bit more creative. Also in the real world, you see Formula E trying out new things to make sure that the races that they do are more engaging for the audience. I think we really need to do more of that to make sure that we actually attract an audience. And that's the only way for esports to mature to the next level. Because we need the audience, because the audience will drive the sponsors. Sponsors will drive up the prize money, and that will make the whole thing more professional. So if we do all of that, I think we should have a bright future in sim racing together. And that's all I had. If you have any questions, if you're here, just talk to me. If you're not here, just write me. This is my email address. I'll try to respond to everything. And yeah, that's it. Thank you very much.
Well, if I'm gonna follow the last 2 speakers we had here in our first summit of the World EX, Belgium.
Dutch.
Dutch. Well, I tried it, but it didn't work. Dutch. It looks a bit like that. That the main focus on motorsport, is in the Netherlands. Is it possible?
Well,
On the other hand, just probably a weird question, due to the fact that Mr. Verstappen is that much successful. Did it help the motorsport, even the esport, in the Netherlands?
absolutely. I think there were a lot more people interested in racing all of a sudden. So that helped the esport. There's more sim centers in the Netherlands being built. There's more people doing the Formula One games, obviously interested in motorsport, also looking at what other drivers are doing. So like guys like Rinus VeeKay, who is racing in IndyCar, all of a sudden people are watching all of that a bit more. So I think that's good. But that's just in the Netherlands, right? And the world is a bit bigger than that. We know that. So we're excited about that, but we also know that yeah, we need to make sure that racing stays popular and becomes more popular in all of the world. Yeah.
What would be heaven for you if you gonna think about the future of esport racing, the sim sport racing? What would be heaven for you?
That's a difficult question. Obviously, if
I'm
I were...
well known for that.
Yeah. I would like to be a bit quicker. I don't know if that's what answers your question. But no, what I would like to see is one thing that you often hear is that that the sort of the wall or the change, the 2 worlds, real racing and sim racing, should be merging. Actually, I don't think that's necessary. I would like to see sim racing becoming a sport on its own. Yes, it's simulating the real racing, and there's a lot of things that both sports can learn from each other. But I would like to see sim racing become a sport on its own.
Do you think there's still a best of both worlds?
Absolutely. I mean, there's things that we can never do in the simulator that you can experience only in real racing, and vice versa. I mean, the biggest problem we have is also one of physics and gravity. We cannot simulate all those G-forces. The only way to simulate all the G-forces is to have a car moving on the track in real life, or build a really big football field with a simulator that runs around the football field, which some car manufacturers are doing to simulate road cars, but they need hundreds of meters of football fields just to simulate some simple maneuvers. So we're not going to be able to do that for racing. So yeah.
But then in the end of the day, and it is kind of end of the day due to the fact that the summit will end with the next one after the next one. The World EX is special for that because we're going to fight with pros and esport pros. So it's absolutely brilliant. Marcel Offermans, thank you very much for being part of the summit here at the BILSTER BERG. Ladies and gentlemen, a big applause for Marcel Offermans.
Thanks for having me.